Good morning. This morning what I want to do is I want to look at page 439 and page 41 of your textbook. And what I want to look at today is I want to look at refraction and how this is linked to your P5 prescribed practical. And what I intend to do today is I intend to look at page 439. So if you turn to page 439, figure 36.8, and I want to look at the refraction and I want to explain the refraction. Then I'll go to page 440 and I'll discuss that figure 36.10 and what's important about it, and I'll try to link it to the video that the teacher has put up. And then finally I'm going to talk about the graph in figure 36.11. Now again, you can't do the practical, but you can read it, you can draw the graph, and you can learn from it. So what I intend to do is I want to just draw out the glass block, and I just want to talk about, so you can see me drawing here. I'm a bit slow, I'm learning every day like yourselves. So there's, hang on, that's a bit coarse, that. So there you have the glass block. Now, the first one I want to show you is, if you look at page 439, figure 36.8, do you see the ray parallel? So I'm going to draw, because I'm going to try to be high tech today, I'm going to draw it in red. There's a ray coming in here, like so, and it strikes this glass block. And because it strikes it at right angles, it simply passes through. And that's the trick question. They'll ask you, what way does that refract? But the answer to that is, it doesn't really refract. Fair enough? So that's the trick question. Now, let's look at side strike. So I'll draw in a normal here. There's your normal. It's a line drawn at right angles to the surface. And we'll do green one. We're going to draw a ray of light coming into this, like so, and it's coming in like so. So we're going here from, this is air here, and this is glass here. So we're going from less dense to more dense. So we're going from less dense to more dense. Less dense to more dense, it'll be bent towards the normal. So it's going to bend towards the normal, so it should go straight on through like this here. That's the way it should go, because light travels in straight lines. But it doesn't. It bends towards the normal. So we're going to bend it towards the normal. And there it is. See the way it is bent towards the normal. Look, that's the way it should have went, but it is bent towards, there's the normal, so it is bent towards the normal. So now I'm going to draw another normal down here. See it in blue there? And then we're going to go here. So again, we're going from glass to air. Glass to air. So it's going to be more dense to less dense. More dense to less dense, away from the normal. So it should go straight like this here, because light travels in straight lines, but it doesn't. It bends away from the normal, so it goes like that. Bear with me. There you are. And there's that ray. Now that's a very important ray. A couple of things are important. That angle, the angle of incidence, that angle from the normal, do you see it there? Look, that angle there, a wee bit bigger. See there, talking about that angle, measured from the normal, is equal to that angle. So that will be one of the questions they'd ask you if they ask you to sketch what way this goes in. So the answer is, it comes in here, comes down, refracts here, less dense to more dense, comes on down through straight, refracts here again, more dense, less dense away, and bend. And that angle up here, that angle here, see that there, that ray, that angle is parallel to that one. See that one? They're parallel. So that's what they're trying to get at there. So when you go to do the practical, which you won't do, when you go to do the practical and you look at figures 3610, you're going to measure two angles. You're going to measure that angle and that angle. See the two angles I'm highlighting there? You're going to measure that angle. That's your angle of incidence. That's going to be I. And then that's going to be R, your angle of refraction. See the language I'm using? Refraction. So there's your angle of incidence, and that's your angle of refraction. And that's what you're going to record in the table. Now, when you look at the video of the teacher doing it, he records I and R. Now, so if you look at figure 3610, you can see I and R that is highlighted in this. Go to table 36.2. Again, we're nitpicking here, but that's what we're here for. Angle of incidence, I in measured in degrees. Do you see that in the table? Mark for that. Angle of refraction, R, measured in degrees. Now, if I was you, and I know that you've done this maybe before, I would plot that graph. Everybody can do a graph until they have to do it. So let's have a look at this here. So I'm going to try to draw a graph on this. Again, I don't have graph paper, so I'll be doing a sketch. I want to make sure I get it right. There's one, and there's the other. Hold on, it's done a bit of a wobbler. There we are. And again, there's 10, 20, 30, 40, 50, 60, 70, 80, measured in degrees, I. And again along the bottom, 10, 20, 30, 40, 50, 60, 70. There's R, measured in degrees. If you go to the table now, and you look R7, you see, am I right about that? Angle of refraction, yes. So, angle of incidence, angle of refraction. Well, you get a graph, something like this here. Right? Just check that graph. If somebody would be kind enough to check that graph for me and just tell me what's happening on it, because there's what the graph looks like. And all you can say is, it's not a straight line, it's a curve. So it's not directly proportional, it's not proportional. All you can say, there's a positive correlation. As R gets bigger, I gets bigger. As R gets bigger, I gets bigger. That's all you can say about it, right? As I increases, R increases. That's it. So now what I want you to do is I want you to go and look at the videos of the practical, draw the graph with the data that's on page 441, and then I also want you to do the quiz, which I will base on the P5, page 440 and page 441. I'll see you shortly.